So in question 15, we are told that we have a fixed mass of gas. We have experiment 1, which provides delta Q worth of heat to the gas at constant volume. Okay, so if the process is carried out at constant volume, this must mean that it's an isochoric process or isovolumetric process. Essentially on my PV graph, okay, PV graph, it looks like this. And because it's just a vertical line, there is no area under the graph. All right, no area under the graph. And by now, we should already know that the work done on the gas is going to be equal to the negative integral of P with respect to V. All right, so this seems a little bit complicated. Basically, the magnitude of the work done on the gas, okay, the magnitude of the work done on the gas is going to be equal to the area under the PV graph, and the magnitude of the work done after we evaluate the area already, we have to determine the sign. Okay, so it's going to be positive if it's a compression, okay, and it's going to be negative if it's an expansion. All right, so this makes sense because if we do work on the gas, we compress the gas, something from the outside is giving energy to the gas. Therefore, the internal energy of the gas must rise, okay, or work is being done on the gas, so it's going to be positive. On the other hand, if let's say the gas is expanding against the environment, this means that the gas is doing work on the environment, meaning the gas is losing energy. So this will give rise to the negative sign. Okay, so in this case, for experiment 1, because it's an isochoric process, okay, essentially there is no work done. All right, and let's talk about experiment 2. Experiment 2 tells us that we have a gas at constant pressure. And if our gas is at constant pressure, this must mean that it's an isobaric process. Okay, so now, if it's an isobaric process, let's just draw the PV graph of a generic isobaric process. Okay, so P and V, okay, we have PV graph, okay, the area underneath the graph, okay, so this means that the magnitude of the work done on the gas, okay, is going to be equal to P times delta V, okay, and if let's say we presume that it's going to be an expansion, okay, if it's an expansion, this would mean that the work done on the gas is going to be equal to negative P times the change in V. Now, in the previous question, I mentioned that the internal energy of my gas, of an ideal gas, is going to be 3 over 2 P times V. Okay, so the change in my internal energy of my ideal gas is going to be 3 over 2 P times delta V. Okay, but from our first law of thermodynamics, we already know that delta U is equal to Q plus W. All right, and if we sub this in as 3 over 2 P delta V, all right, and we sub this in as the work done on the gas, negative P delta V, okay, and we make Q the subject of our formula, Q is going to give us 5 over 2 P delta V. So immediately, we can see that the magnitude of Q is going to be greater than the magnitude of W. All right, so let's just keep this in mind first. Okay, so for this particular question, they want us to evaluate which statement about these two experiments is correct. Okay, so the first statement says that the work done by the gas in experiment 1 is greater than delta Q, and this is obviously false. Why? Because I mentioned already that there was zero work that is done. Okay, so this is immediately wrong. Now, for B, they told us that the increase in internal energy of the gas in the experiment in 1 is equal to delta Q. So this is actually true. This is actually true because as mentioned, we have delta U equals to Q plus W, but because W is equal to 0, delta U is going to be equal to delta Q. So B is thus far the most plausible answer. Okay, but let's just check the rest just to be thorough. The work done by the gas in experiment 2 is greater than delta Q. Alright, so as mentioned, the delta Q, okay, I've already shown you that the magnitude of the heat supplied to the gas must be greater than the magnitude of the work done on the gas. Okay, so this is definitely false. Alright, and finally, the increase in internal energy of the gas in experiment 2 is equal to delta Q. Okay, and this is also going to be incorrect because we also know that delta U is going to be equal to W plus delta Q. Okay, so the W also has a contribution, so it's not going to be equal to delta Q alone. Alright, so D is also false. Therefore, our answer is B.